A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
Hoping for more interspecies dialogue following this groundbreaking exchange.
Deep beneath the waves, a hidden language has been echoing for centuries. Fast, rhythmic clicks, exchanged by creatures with minds more complex than we ever imagined. Now, powered by cutting-edge AI, scientists are finally beginning to decode these underwater conversations. But what they're uncovering isn't just communication, it's something far more unexpected. Not simple signals, not basic calls. What they found is rewriting everything we thought we knew about intelligence, language, and who, or what, we share this planet with. The sound that changed science forever. Long before artificial intelligence entered the scene, the ocean had already been carrying on a conversation. We just didn't know how to interpret it. For centuries, sailors spoke of strange, echoing sounds drifting across open waters at night. Deep, almost haunting calls that felt too deliberate to be random. Still, for most people, these sounds remained nothing more than part of the ocean's mystery. That perception began to shift in the 1970s. During a growing wave of environmental awareness, scientists turned their attention to humpback whales. Equipped with early underwater recording devices, researchers began capturing their vocalizations. What they uncovered was astonishing. These weren't scattered noises, they were structured, repeating sequences that evolved over time, sometimes lasting for hours. It was unlike anything anyone had heard before. These recordings were eventually compiled into an album titled Songs of the Humpback Whale, and unexpectedly, it reached far beyond the scientific community. The public was captivated. People weren't just hearing whales anymore, they were connecting with them. That emotional impact helped fuel a global conservation movement, playing a key role in protecting whales from the brink of extinction. But scientifically, the discovery raised more questions than answers. What exactly were these whales saying? Were these sounds used for mating, warnings, navigation, or something far more complex? Despite years of research in bioacoustics, the study of animal sounds, scientists couldn't fully decode the meaning behind them. The patterns were clear, but the language remained locked. For decades, progress stalled, not from lack of effort, but from limitation. The human brain simply couldn't process the overwhelming volume and subtle variations within whale communication. Then came a radical idea. Dr. David Gruber, a marine biologist and National Geographic explorer, proposed something that sounded almost like science fiction. Instead of treating whale sounds as simple signals, what if they were part of a structured language? Inspired by CETI, the search for extraterrestrial intelligence, he questioned whether humanity had been looking for intelligent communication in the wrong direction. What if the other intelligence we were searching for wasn't in space, but in the ocean? This bold thinking led to the creation of Project CETI, the Cetacean Translation Initiative. But unlocking a language unlike our own would require more than curiosity. It would take an entirely new kind of collaboration, one that brought together minds from worlds that had never worked side by side before. Assembling the Dream Team for CETI. Project CETI wasn't going to crack the whale language with marine biologists alone. Dr. David Gruber knew that to unravel the mysteries beneath the waves, he needed a team unlike any other, one that combined deep-sea expertise with cutting-edge technology and linguistic genius. At the heart of this team were the people who had spent years living among whales. Shane Giro, a marine biologist with over a decade of research near Dominica, was a perfect example. He didn't just study whales, he knew them personally. He tracked a single sperm whale family, giving them names and observing their behaviors as they grew. His years of fieldwork became the foundation for CETI, offering an intimate understanding of the whale's social dynamics that no technology could replace. But field expertise alone wouldn't solve the puzzle. This is where AI and natural language processing entered the scene. Before Project CETI, translating whale communication was considered science fiction. The complexity and volume of data made it impossible for human ears to decode, and traditional research methods could only go so far. Around 2019, the team realized that emerging AI technologies could do what decades of manual analysis never could. Machine learning could sift through millions of vocalizations, find patterns, and help uncover the structure of whale language. Dominica, with its unique volcanic geography and deep waters close to shore, became the perfect laboratory. The island offered stable whale populations, with many families returning annually, a natural advantage for long-term study. It was here that the team would build their ambitious setup, a 20-kilometer by 20-kilometer underwater listening studio designed to identify who was speaking, to whom, and in what social context. This was more than recording. It was creating the framework to understand the whale's world. Funding from the TED Audacious project, totaling $33 million, turned ambition into reality. The initiative allowed the team to construct an unprecedented hydrophone network and deploy advanced robotic systems to track and record whales non-invasively. Biologists guided the AI experts, while computer scientists transformed raw data into analyzable patterns. It was an extraordinary collaboration, merging biology, technology, and linguistics in a way never done before. Even with all this, the challenge remained daunting. How do you capture every sound in the deep ocean without disturbing the whales? How do you know who's speaking and what they mean? The CETI team was on the edge of a technological and scientific frontier. Every click and coda they recorded was another piece of a puzzle that could finally reveal what these magnificent creatures were trying to say, and prepare the stage for the tools that would allow them to understand it. And that's where the real technology came into play. A combination of hydrophones, robotic tags, and AI that would transform raw sound into a decipherable language, ushering in the next chapter of discovery. The underwater tech that changed everything. To truly decode whale communication, Project CETI needed more than human ears. It needed a technological leap. That leap came in the form of hydrophones, essentially high-tech underwater microphones. Placed across a vast grid on the ocean floor, these devices recorded every sound, 24 hours a day, capturing clicks, moans, and whistles with astonishing clarity. The network acted like an enormous surveillance system for the deep, pinpointing exactly which whale was speaking and when, a feat that decades of manual study could never achieve. But capturing sound was only half the battle. How could researchers know the context behind each call? Enter the robotic fleet. Autonomous drones and specialized robotic systems capable of gently attaching non-invasive suction cup tags to the whales. These tags recorded not only the audio, but also tracked heart rate, movement, depth, and social interactions. Suddenly, each click and coda could be linked to specific behaviors, providing the crucial context needed for AI to interpret the meaning behind the sounds. The scale of data being collected was unprecedented. Past research might have captured hours or days of whale songs. Project CETI amassed millions, billions of vocalizations. It was a colossal library of whale communication, essential for machine learning models to detect patterns invisible to the human ear. AI could now sift through this ocean of noise, learning from every click and pause, every subtle rhythm or inflection, and gradually build a framework for understanding the language. What once seemed like a single, inscrutable hum of the ocean was transformed into a treasure trove of structured information. The raw, chaotic sounds became analyzable sequences, each linked to behaviors, relationships, and context. Yet, even with this breakthrough, the whale's messages remained mysterious. It was here that the magic of AI would take the stage, turning endless data into the building blocks of a language. With hydrophones capturing voices from afar and robotic tags supplying context, the stage was set. The next step, feeding all this information into machine learning models, would be the turning point. This was where the invisible patterns of whale communication would finally begin to emerge, revealing a complex linguistic world that had been hidden in the depths for millennia. And that is exactly what the team tackled next, letting AI do what humans could not: decode the deep. Decoding the language of giants. Even with millions of recordings and mountains of behavioral data, the ocean's voices were still just noise to human ears. To make sense of it all, the Project CETI team turned to AI. The first challenge was translating sound into something the computer could understand. They used spectrograms, visual representations of audio, turning each click, moan, and whistle into patterns the machine could see. Suddenly, the chaos of the deep became a canvas of data, where each line and spike held a potential meaning. Once the sounds were digitized, advanced machine learning and deep learning models entered the scene. Unlike humans, AI could analyze millions of vocalizations simultaneously, finding patterns invisible to even the most experienced biologist. The system wasn't told what the clicks meant. Instead, it learned from context, observing which sequences appeared together, how rhythms shifted in different social situations, and how whales responded to each other. Over time, the AI began recognizing the building blocks of communication: subtle variations, repeated sequences, and tiny pauses that human ears would miss entirely. The results were astonishing. The AI uncovered a structured system in the sperm whale codas, almost like a phonetic alphabet. While whales don't have letters, they do use rhythm, tempo, and ornamentation, small clicks at the start or end of a sequence, to convey meaning. Change the tempo, add a click, or alter a rhythm, and the message could transform entirely. It was a level of complexity previously thought unique to humans. This wasn't random noise or mere survival signals, it was language. And just like any language, context mattered. The AI revealed that whales' communication could vary depending on social interactions, hierarchy, or even emotional states. It showed a system far richer than anyone had imagined, proving these giants of the deep weren't just singing. They were conversing. But understanding the structure was only half the story. What did these sequences actually mean? What were the whales saying to one another? And how did their words relate to their society and culture? This was the mystery that Project CETI would tackle next, moving beyond patterns into meaning, culture, and emotion, the hidden world behind the clicks. With AI revealing the grammar and syntax of whale language, the team was ready to explore the next frontier, the whale's social world itself, where communication wasn't just sound, it was identity, connection, and culture. The secret lives of whales. For decades, scientists assumed that if whales had a language, it would be simple: practical calls for survival, mating, or warnings. But the AI told a very different story. Instead of functional signals, it revealed a rich tapestry of communication, deeply tied to social interactions and relationships.
They aren't just used for echolocation. Sperm whales and dolphins also use clicks for communication, and inside of those clicks is probably one of the most sophisticated forms of communication we've discovered on the planet. Could be more sophisticated than human language.
Whales weren't just exchanging information. They were connecting, expressing, and even talking about their lives. The AI uncovered subtle variations within codas, tiny rhythmic shifts, and nuanced pauses that could completely alter meaning. These were not random quirks. They were deliberate choices, much like how humans use tone, inflection, or emphasis to convey emotion. For example, a brief pause in one whale's sequence could indicate curiosity or caution, while a rapid tempo could signal excitement or urgency. Ornamentations, the extra clicks at the beginning or end of codas, added another layer of subtlety, creating a system sophisticated enough to rival human speech in complexity. Even more fascinating was the discovery of dialects. Different whale clans used unique patterns, like distinct accents or regional phrases, that identified them to outsiders. A single coda could carry multiple layers of meaning depending on rhythm, context, and the specific clan speaking. This meant that whale communication wasn't universal. It was a living, evolving reflection of their culture and social identity. By decoding these patterns, Project CETI began to glimpse the whale's social universe. They saw evidence of cooperation, play, emotional expression, and even mentorship, as older whales guided younger ones. It was a window into a world we'd never known existed, revealing a level of intelligence and societal complexity previously unimaginable. Yet this breakthrough posed a new, thrilling question. If we could understand the language and social context of whales, could we go further? Could humans respond, not just listen? With AI providing a blueprint for structure and meaning, the team realized they were on the verge of something extraordinary. A chance for real-time, two-way communication. They weren't just decoding a language, they were laying the foundation for conversation, bridging the gap between species in a way humanity had never attempted before. The stage was set for the next bold step. Understanding was only the beginning. Now came the era of interaction, dialogue, and the audacious dream of speaking to whales on their own terms. The first conversations with whales. For decades, humans could only eavesdrop on the conversations of whales, listening without comprehension. But thanks to the AI models developed by Project CETI, the dream of real dialogue was suddenly within reach. With a detailed map of whale language, codas, rhythms, ornamentations, and dialects, the team could not only understand the whales but also craft responses in their own linguistic style. The goal was ambitious, a real-time, two-way conversation with one of Earth's most intelligent species. To achieve this, the team developed specialized underwater speakers capable of reproducing codas with perfect precision. The idea was simple but daring: play a sequence of clicks that mimicked whale communication and wait for a reply. These weren't just random noises. Each playback was carefully constructed using AI insights to reflect social cues, timing, and context. In other words, humans were attempting to talk to whales on their terms, not the other way around. The first successful exchange happened in 2023, marking a historic moment. A diver released a sequence of sperm whale clicks designed as a greeting. Moments later, a whale returned the exact same coda. The team realized this wasn't a coincidence. It was a conscious response, an acknowledgement, a hello in whale terms. This single, simple interaction demonstrated that the whales could understand the structure of the messages and respond appropriately. Humanity had bridged a gap that had seemed insurmountable. Yet the breakthrough raised profound ethical questions. Should humans be communicating with another species? Could our presence and technology disrupt natural behaviors or influence their social culture? Project CETI approached these concerns with extreme caution, emphasizing that the interaction must respect the whale's autonomy and social norms. Every step of communication was designed to be non-invasive, ensuring that the whales remained in control of the conversation. This step into two-way dialogue represents more than just scientific achievement. It challenges our understanding of intelligence, consciousness, and our relationship with other species. We've gone from observing behavior to participating in it, from interpreting sounds to co-creating exchanges. The potential implications are staggering. If we can communicate with whales, we may unlock new ways to interact with other intelligent life forms on our planet, and perhaps one day beyond it. With these first successful exchanges as proof of concept, Project CETI is now preparing for the next phase, expanding the vocabulary, experimenting with more complex interactions, and refining AI to interpret nuanced social cues. This isn't just about greetings, it's about understanding whale thought, emotion, and culture at a deep level. The project is pushing the limits of biology, linguistics, and AI simultaneously. As humanity stands on the edge of interspecies conversation, the question arises: what can we learn from whales about intelligence, communication, and our own place in the natural world? The stage is set for a revolution in understanding, one that may change how we see life, both on Earth and beyond. The future of interspecies communication. The success of Project CETI has opened a door that was once unimaginable, understanding a non-human language at a level once thought to be exclusive to humans. For decades, marine biologists could only observe whales, recording their behaviors, mapping migrations, and guessing at the meaning of their songs. Now, with AI decoding millions of codas, clicks, and vocal patterns, we can glimpse the structure of their communication, and in some cases, even their intent. The whales are no longer just objects of study. They are conversational partners. This revelation reshapes how we think about intelligence itself. Whales exhibit a level of linguistic sophistication that challenges the human-centric view of communication. They use rhythm, tempo, and subtle ornamentation to convey complex social information, emotion, and identity. Different clans or families even speak with distinct dialects, proving that culture is not uniquely human. By listening and learning, we are beginning to understand not just what they are saying, but how they see the world, a window into their social dynamics, memories, and perhaps even a sense of self. Beyond the ocean, Project CETI has implications that reach for the stars. Named deliberately after SETI, the project offers a blueprint for deciphering entirely alien languages. If extraterrestrial life exists and communicates in ways we cannot yet imagine, the algorithms, pattern recognition models, and AI strategies developed to decode whales could be adapted to interpret signals from the cosmos. In a sense, our first interspecies conversations may be training us for interstellar dialogue. On Earth, this research fosters empathy and a renewed commitment to conservation. Whales are no longer distant creatures. They are intelligent beings with complex societies that deserve protection. Understanding their language strengthens the argument for safeguarding their habitats and the broader ocean ecosystem. When we hear the nuances of their clicks, we hear culture, family, and social connection, reminding us that intelligence is not confined to humans. As Project CETI continues to expand its reach to other species like orcas, and as AI grows more sophisticated, the possibilities feel limitless. This isn't just about science, it's about forging a connection with life forms we've shared the planet with for millennia. The whales are speaking. For the first time, humanity is truly listening. Don't forget to like, subscribe, and tap the notification bell so you never miss our latest discoveries. Dive deeper, click the next video, and keep exploring the wonders of our world.